Fever, cough, sore throat, runny nose, headache. We have become far too familiar with these seemingly inconspicuous symptoms. A year and a half later, the world is still grappling with the invisible and deadly COVID-19. While the virus initially attacks the respiratory tract, late stages of disease are associated with sepsis, a multi-organ dysfunction caused by a dysregulated immune response. This systemic inflammation can damage the brain, heart, and GI tract. And with only 2% of people in low-income countries having received their shot, the world's most vulnerable communities are struggling. Given the lack of approved drugs, it's becoming increasingly important to explore novel therapies to address this deadly inflammatory disease. This summer, we turn to our body's endocannabinoid system, the same system that cannabis acts on. And while cannabis does have anti-inflammatory properties, it's limited by its psychoactive side effects. This is due to its interaction with CB1 receptors, located primarily in the central nervous system. CB2 receptors, on the other hand, are mostly expressed in the periphery. These are also anti-inflammatory, but without the psychoactive side effects. As such, CB2R agonists could be promising candidates for treating the systemic inflammation in COVID-19. And that's exactly what we investigated this summer. To emulate the pathophysiology of COVID-19 while minimizing contamination risks, we used a bacterial model of lung infection. As shown here, we anesthetized a mouse and employed intranasal administration of LPS. This component of bacterial cell walls activates several of the same systemic inflammatory pathways as SARS-CoV-2. Following inoculation, to monitor this systemic inflammation, we used intravital microscopy for in vivo visualization of white blood cells in the intestines. Without treatment, the LPS caused significant white blood cell adherence to the vessel walls, as shown in the red circle, suggesting significant systemic immune activation. However, upon treatment with a synthetic CB2R agonist, there was a significant decrease in the number of adhering white blood cells. It was binding its CB2 receptors, preventing immune activation, and mitigating systemic inflammation. Our research this summer showed that the endocannabinoid system and CB2R agonists are promising candidates to treat not only COVID-19, but other hyperinflammatory diseases as well. We have a global responsibility to protect those that have been neglected in vaccine distribution, and this might be one way to do it. Thank you.